Okay, hi Year 10. So today we're going to do a video lesson of our lesson, which is a little bit like what you will do next year in Year 11 for both standard and advanced maths. So it's a good practice at having that understanding that you go to a video, you'll learn your work, and then you can take that information that you don't know back to class and talk to your teacher about it. So what we're going to have a look at today in our lesson is the exponential function. So remember, a function is just a graph, basically. So it's an exponential. We're going to have a look at its equation, and we're going to have a look at the graph that goes with the equation. Because remember, in maths, most of the topics that you're going to have a look at from now on are going to have a picture that matches the algebra-based equation. So our learning intention for this lesson is to be able to sketch graphs of exponentials, be able to sketch with some reflections, and maybe solve some equations. We'll see how we go. Okay, so you should have this worksheet with this information on the desk in the front of the classroom. So make sure that you get that given to you and you work from that, and you can glue that in your books at the end. Okay, so what we're going to have a look at with exponentials are graphs that look like this here. Y equals 2 to the power of the x. Y equals 3 that has a power of x, and y equals 3 that has a power of minus x. So what you can see with those three equations there is that the x sits in the power, and that's what makes an exponential. We're going to have a look at these things called an asymptote. So our exponential graphs have an asymptote, and an asymptote is a line that the curve approaches by getting closer and closer to it but never reaching it. So we haven't seen asymptotes really, I don't think at all so far up until Year 10. And we'll have a look at that in our picture in a second. So if you move over to the diagram over here, we've got our x and our y axes here. And here, this blue line here is a graph of y equals 2 to the power of x. So what we could do is we could use our old-fashioned way and plot the points that make up that curve by doing something like this, by getting a whole heap of x values down from minus 2 up to 2. In this example, that's what I would do. I could go for any number to any other number and get our values. And I would pop those values of x into y equals 2 to the x. So if I pop, so let's start in 0. 0 into here gives us 2 to the power of 0, which is actually 1 if you pop that in your calculator. And what you will find that any graph that has a power of x in its power, well, most graphs will, we won't say any graph, most graphs will cut at the point 0, 1, because we're going to get a 0 power, which means that anything to that 0 is equal to 1. So that's a really important point. What we find that is we put 1 in there, I get 2 to the 1, which is 2. And if I put 2 in there, I get 2 to the 2, which is 4. So we can see that our numbers here are getting larger and our graph here is getting larger. But something different happens when I pop a negative in there. When I pop a minus 1 into that power, I get 2 to the minus 1, which is, I'll pop in there as 2 to the minus 1, which is going to be equal to what? Pop it in your calculator, which is actually equal to a half. And 2 to the minus 2, if you pop that in your calculator, if you can't find where to do that on your calculator, I'll pop mine up there. I'm going to be going 2, and the little button that I want to press is up there because it raises that number I've got there to some other number. So 2 to the minus 2, what am I going to get? I'm going to get 0.25 or 1/4. So I've got a quarter there. So what you can see is on the left-hand side of the 0, my graph's starting to get smaller and smaller and smaller. Now, I'm going to show you something quite interesting. If I picked a number on the x-axis way out here somewhere, let's say, for example, oh, I don't know, minus 20, for example. Maybe we'll just go minus 10. If I had an x value of minus 10, and I pop that in my calculator, 2 to the minus 10. What's that? Let's go and have a look. I'll pop that in there. Oops. Two to the power of minus 10, what you're going to get is a number that is really, 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 really tiny. But it's not equal to 0. It's just getting there. What if I popped in a bigger number in the power? 2 to the power of minus, oh, let's go 50. What am I going to get? a tinier number. That minus 16 there tells me there's 16 numbers that side of the 8. So what we're getting, is, I'm going to write there a small number there. This curve here will continue on and on and on and on and on. It will never ever get to 0. So if even you were to put into that power of x a number of minus 1 million, so you're way down here, you would never ever get a 0. Now your calculators actually can't deal with that sort of number, but a computer could. But what that's telling us is that curve never cuts that axis, it never touches that axis. So what we say is that x-axis in this curve is called an asymptote. Okay, so an asymptote is a line that a curve approaches by getting really close, but it never actually reaches it. So our exponential gets really close to the x-axis, or it's also called the line y equals 0, because y is 0 there, but it never actually touches it. So an asymptote is a word you're going to deal with a lot in advanced next year. And next thing here says exponential graphs are functions because every x value has exactly one y value. So I showed you guys the other day, Mr. McDonald did, that if we were to draw a line through a curve, if that line that's horizontal only touches that curve at one point, then we would say that it's a function. And that's, again, more year 11 stuff. Okay. All x values are permissible. That basically means I could pick any x value and I would get a matching y value. I, however, can't have any y value because my curve doesn't go below that x-axis. So I only have y values that are greater than 0 involved in that curve. So that's another thing to think about. Let's go down a little bit further. So a simple exponential rule is of the form y equals a to the x, where that a could take on any other number, but it has to be 0. We don't want it to be a negative number. And we generally don't say it's equal to 1. So there are two things that we don't do. The y-intercept is 1. So remember on the curve up above here, you cut the y-axis here at 1. Well, have a look over here. In this case, our graphs, that red one there is y equals 2 to the x. The blue one just goes the other way. It just flips that curve around, and that's what the negative does, is y equals 2 to the minus x, but they both cut there at the point 0, 1. And that's part of the definition of that curve. What you will see is when there's a minus in front of the x, it reflects that curve around the y-axis. If you were to put a minus in front of the 2, like this green curve down here, it basically reflects that red curve along the x-axis. And they're two important things that we'll look at a little bit next year. And that's what these 2 points here are talking about. Now, I want you to scroll down a little bit, and what you'll see on your sheet is an x and y axis. So if you want to pop x and y on there, and what I want you to do on that axis now is to plot a curve y equals 2 to the x using your x values here. You're going to get your y values. So substitute your x value in, it'll shoot out a y value. You'll pop that down below, and I want you to plot that, okay? And it's going to go through this point here. Once you've done that, I want you to do it to y equals 3 to the x and 4 to the x, and I want that to be all on that same curve as well. So for 3 to the x and 4 to the x, if you pop your x and y and your x values along the top of those, and then what you can do is, for each of them, find your y values. And that will give you 3 curves on here. And I want you to plot the 3 of them together, please. So I'll probably pause the video now. And what you'll get are 3 curves that look similar to this, but I want yours to be hand-drawn on yours. And what you will find is they'll all go through 0, 1. The 4 will be steeper than the 3 and the 2 on the right-hand side. But down below, on the negative x values, you'll get the blue one, which is the 2 being higher than the 3 and higher than the 4. They'll all move along that axis, along here, but they'll never actually touch the axis. So I would like you to plot those yourself, please. Now, if you turn your sheet over, what you will find on the back is another axis, Cartesian plane, and you'll have your x and your y axis there. And what I'd like you to draw on there, again, is 3 to the power of x. You can use your values that you got up above here, okay, your x and your y values, and plot those down below. Once you've done that, I want you to think about, what does y equal 3 to the minus x look like? And we looked at that right up at the start up here. Okay, we did it with 2 to the x. So I want you to have a think about what that would look like. And what the minus there does, the negative in the power, and I'll get you to write this on your sheet, okay, because I'm not going to have that on your sheet. The negative in the power reflects the graph. Can you think where it reflects it? All right, reflects y equals 3x in the y-axis. So what you're going to get is, if this y-axis was a mirror image, it's going to flip that exponential curve and it's going to have it going the other direction when the negative is up there. And that's really important. The other thing we want to have you draw on there is y equals minus 3 to the x. So it's basically 3 to the x with a negative in front of it. So what you'll do is you'll just go up here and you'll just pop a negative in front of your values that you've got. And what it's going to do, it's actually going to reflect your exponential. It is moving up here, your 3 to the x. Okay, it's going to reflect it down here. And it will look like, oops, there we are, the green graph up here that's reflected the red one. So I want you to have a go at drawing those. And what you will write under here is that a negative in front of the 3 reflects y equals 3 to the x in the x-axis. Okay, so you're going to have the x-axis a mirror and it reflects it. Now, go back up to the one above. I want you to change that to a positive because there's a little mistake in there. We'll get rid of that little line altogether. Okay, so I want you to pop those in there. Okay, and then we're going to have a look at one more little question for you to do today. The question I want you to look at now is, it's going to be solving an exponential equation. And it's basically a simultaneous equation, but, and we've been looking at those for the last couple of weeks, but it's an intersection or a simultaneous equation of the curve y equals 2 to the x and y equals 8. So we want to find where those two graphs would intersect. So let's look at it algebraically first. Y equals 2 to the x is our first equation, and y equals 8 is our second equation. So you'll need to write this down on your sheet, and we're going to sub one into the other. In this case, because they're both equal to y, I can actually just let that 8 equal that y in there. So I'm going to have 8 equals 2 to the x. Now, mathematically, there's actually two ways to do this, and we're going to look at it quite simply this year, but there's a way with a thing called a logarithm to do that in year 11, but we don't need to know that now. But we've got a 2 with a power. So we need to think, well, how can I write 8 as a power of 2? So we think, well, 2 to the power of 1 is 2. 2 to the power of 2 is 4. And 2 to the power of 3 is 8. So I can write that 8 as 2 to the power of 3. And that's going to equal 2 to the power of x. So what we're going to do is this thing called, and this is probably new to you, but it will make a lot of sense, is called equate powers. So because my bases are the same number, I've got a 2 to the 3 and a 2 to the x. These powers must be identical. So I can say that x equals 3 is where they're going to be equal. And that's the solution, the x value to the solution of my intersection. And I want to find my y value when x is 3. This is an easy one. We've already got a y value there. Y is 8. So I could draw that. We might quickly have a look and see what that looks like when we draw it. I'm not going to put a graph on there for you this time. You can draw your own little x and y axes. There's my x and there's my y. I know that 2 to the x looks like this because we've had a lot of practice at drawing it today already. Y equals 2 to the x. And I'm going to find where it equals y equals 8. Now, where's y equals 8? If that is 1, y equals 1. Y equals 8 is all up here somewhere. Y equals 8 is a straight line that's always 8 no matter what value x is. So in this case, the intersection would happen at the point, that little point there, that would be 3. And there's my 8 up there. Okay, so I've got 3 and I've got 8. So the intersection's happening at this point here, which is the point 3, 8. So I'd like you to draw that in there as well. Now that you've done that, what you're going to do is jump over to the OneNote. You're going to have a look for the exponential functions, and I'm in the 5.3 tab. We're going to go down to exercise 9J, and I'm going to highlight some questions in blue there for you to have a look at. So you're going to stick your sheet in your book. Coming to 9J, we're only going to have a look at the blue questions. The only blue questions I need you to have a look at are 5, 7, and 9. So get those in your book, mark them, check that they're okay. If you haven't completed the circle questions from last lesson on 9I, then you need to go back and make sure that you can do those. Okay, there's not many in there. If you're stuck on those, you will use the notes that we looked at from last lesson to work on those as well. Okay, and those notes are in that OneNote as well under further functions. So there's lots for you to work through. You could have done the functions before this video if you like as well on the circles. But plenty to do. This will be in your next assessment task, and I'll also leave you some maths online work if needed.